Hi, Hustler here, just giving you notes on 3.5, taking a higher derivative. So a higher derivative is obtained by repeatedly differentiating a function. And so if I have the function y equals f of x, then I could look at taking the derivative, which would be y equals, or y prime, equals f prime of x. And we know how to do that. But if I want to take the derivative again, that's known as taking a second derivative. And a second derivative means that I'm going to take the derivative of the first derivative. Okay, so if I am taking the derivative of f prime, I would have f double prime. In other words, what this notation here is showing is that I take the derivative of f prime. The derivative of f prime is known as the second derivative, or f double prime. Okay. Another way to think about this is that the second derivative is the rate of change of f prime. Okay, so if I go back to this idea that f prime is the rate of change of f, then again, f double prime of x is the rate of change of f prime. Graphically, the second derivative is the slope of the tangent line for f prime, okay? And the notation, f double prime of x, or in Leibniz notation, would be d squared y over dx squared. That represents the derivative, or the second derivative. If I were looking for the third derivative, I would use f triple prime of x, or d cubed y over dx cubed, and so on. Once we move beyond a third derivative, you can see in problem 2. In problem 2, we have this f4 of x, meaning find the fourth derivative. So beyond the third derivative, we stop using those like tick marks, and we just start indicating numerically what derivative you would be taking. So I'm going to go through some examples here. I'm just going to do one or two examples, and then you need to try the remaining examples to see what you can come up with. So I'll do examples 1 and 2. Okay, so it says calculate f double prime of -1, given that f of x is equal to 3x to the 5th minus 2x squared plus 7x to the -2. Okay. The first thing I would suggest doing is finding the generic derivatives. So before I worry about substituting -1 in for x, I would first worry about getting to the second derivative. And in order to evaluate f double prime of x, I must first evaluate the first derivative. Okay, so I'm going to first find f prime of x, which means I'm going to take the derivative of each individual term. That would give me 15x to the 4th minus 4x, and then minus 14x to the -3, right? I got to subtract 1 from the exponent. Now I'm going to take the second derivative, and all that means is I'm going to take the derivative of the first derivative. So I'm starting at this f prime of x, and I'm going to take the derivative of that function. So I'm going to have to apply the power rule. That's going to give me 60x cubed minus 4. And -3 times -14 is plus 42. Subtract 1 from the exponent, x to the -4. And so now I have found the second derivative. And now that I have found that second derivative, I'm going to go ahead and evaluate at -1. So now I'm going to say f double prime of -1 means that I'm substituting -1 in every place there's an x. Well, I don't like that there's x to the -4. My brain doesn't process negative exponents. So I'm going to rewrite that x in the denominator to the +4 and then substitute -1 in for that. And as you can see, I am quickly running out of space. So negative 1 cubed is negative 1 times 60. So it's negative 60 minus 4. Negative 1 to the fourth is positive. 42 divided by 1 is 42. And negative 60 minus 4 plus 42 is negative 22. So I know that I'm out of space. You're just going to have to bear with me. What this means is that f double prime of negative 1 is equal to negative 22, given my original function of f of x being equal to 3x to the fifth minus 2x squared plus 7x to the negative 2. Okay, so when you have to evaluate at a specific function, my suggestion is to work through the generic derivatives and then evaluate for that specific number. All right, I think I can do problem 2 without having to erase. So what I'm going to do is I'm just going to draw this line here. There we go. You like my sound effects? Okay, and I can go ahead and start with number 2. It says calculate the fourth derivative of x, given that f of x is equal to sine of x. So I don't have to evaluate this for a certain number, but I do have to run through 4 derivatives. So again, you start with the first derivative, f prime of x, and the derivative of sine is cosine of x. And then I'm going to run through the second derivative, which means I'm taking the derivative of the first derivative. I'm taking the derivative of cosine. And the derivative of cosine x is negative sine x. I'm going to take the third derivative. And so remember the derivative of sine of x is cosine of x, but I have this negative coefficient in front. So negative cosine of x is the derivative of negative sine of x. I'm going to take the derivative of that function. So that's going to be my fourth derivative. All right, the derivative of cosine is negative sine, but I have this negative coefficient in front. So negative 1 times negative sine of x is a positive sine of x. So what's super cool about trig functions is that when you run through the derivative 4 times for sine of x, you land back at sine of x. Okay, there's this cycle there. And the same thing would hold true for cosine as well. Okay, so your job is to do 3 and 4. And if you notice, I wasn't very kind, was I? Because in 3, it looks to me like you have a composite function to deal with. And in 4, you got 2 functions happening there. You got to think about what to do with those. So do your best. We'll go over this in class. And you're going to turn in this document on Classroom.